Calculus. Let's go ahead and go through these multiple choice questions. Feel free to scroll around the video to find the questions you need. All calculator active. So we're going to start with question 76. There are not 76 multiple choice questions. They just have you turn your Scantron over for the calculator active part. So that's why the numbering feels kind of weird. So 76, a particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given by v of t. What's the acceleration at time 6? So if I would know the acceleration of the particle at time 6, that's equal to the derivative of the velocity at time 6, which for our since it's calculator active, we will go math 8. So let's do that together. We can go math 8 d dx, and then I'm going to put my function in, so x squared times ln of x plus 2, and evaluate that at x equals 6. And so 29.453 if you truncate, so C. Question 77. We've got the integral from 0 to 3 of f of x is 6, and then from 3 to 5 is 4. So if you think of that kind of as area, then we know that the integral from 0 to 5 of f of x dx is 6 plus 4, which is 10. We want the integral of the quantity 3 plus 2 f of x dx. Notice that you've got two terms in your integrand, so let's split this into two integrals. So one integral going from 0 to 5 of 3, and then close that up, dx, plus another integral from 0 to 5. Let's bring out that coefficient of 2, and then in the integrand, f of x dx. All right, so for the first integral, remember two ways to find a definite integral, and that is area under the curve or antiderive. So for this one, we will antiderive and evaluate that at 5 and 0. And then for this one, we know that this integral is equal to 10. So for the red piece, I've got 15 minus 0 plus 2 times 10, which is 20. So 15 plus 20, we should be getting 35. 78. For time greater than or equal to 0 hours, h is a differentiable function of t that gives the temperature in degrees Celsius at an Arctic weather station. Which of the following is the best interpretation of h prime of 24? Okay, so t is in hours, notice. And h is a differentiable function that gives the temperature in degrees Celsius at an Arctic weather station, all right? And we want to interpret the derivative. And remember, the derivative gives you the rate. So I can automatically, let's write this for our correction. So derivative implies rate. So I can automatically take out A and B. I can actually take out C as well, because let's write this, it's instantaneous rate. Okay, it's not the average rate, it's the instantaneous, right? In other words, it should be what is going on right at 24 hours, okay? So it's not the rate at which the temperature is changing over a time interval. That's more of an average rate of change. This is what happens right at the end of the 24th hour. So we should have E, and for your correction, all I need to see is that. 79, a spherical tank contains 81.637 gallons of water at time t equals 0 minutes. For the next 6 minutes, water flows out of the tank at a rate of gallons per minute. How many gallons of water are in the tank at the end of the 6 minutes, okay? So, first of all, are there any of these I could just take off right away without even doing anything? Okay, if we start with 81 and we're losing water, we can't end with 126. So, we are going to start with 81.637, and then we need to subtract out how much has left, right? So from 0 to 6, 9 sine of the square root of t minus 1 dt. So let's put that in our calculators. We've got 81.637 minus math 9 from 0 to 6, 9 sine of the square root of x plus 1 dx. And I'm getting 36.606 if we round, so A. Question 80. A left Riemann sum, a right Riemann sum, and a trapezoidal sum are used to approximate the value of the actual area, right? The integral from 0 to 1 of f of x dx, each using the same number of subintervals. The graph of the function f is shown in the figure above. Which of the sums gives an underestimate of the actual area? So the integral would give me all of that area filled in, right? And so we want to know which one's underestimate. Well, this function is increasing, meaning that, and we're just going to pick a subinterval here, meaning that the left y value is always smaller than the right y value. So you can see that if I picked that particular subinterval, that would give me an underestimate. So we'll keep left, meaning the right sum will not, right? So left gives an under, right would give an over. Then for trapezoidal, if we connect the endpoints here, we can do any subinterval, we can see that trapezoidal will also sit under. So left and trapezoidal will be under, and that will be option D. 81. The first derivative of the function f is given by f prime of x. How many points of inflection does the graph of f have on the interval 0 to 2 pi? So you're going to do this like you would a graphical FRQ. So let's first graph what's given, keeping in mind that's the derivative. So remember that according to our diagram, if I want to know how many points of inflection f has, remember we go concave up, concave down, increase, decrease, plus, minus, right? So for a point of inflection on f, that means f changes concavity, which would mean the given graph, f prime changes from increasing to decreasing, or vice versa. So grab your calculator. Let's start by graphing this. Pause if you need to. We've got x minus 4e to the negative sine of 2x. Okay, and we want to graph this on the interval 0 to 2 pi. And we, again, here are going to need to see, okay, when do we change from increasing to decreasing? So why don't we start with negative 10 to 10 on the y's, and we can adjust if we need to. So let's graph. I see a change there. Once, twice, 3, 4. Looks like 4 times that f prime changes from increasing to decreasing, or vice versa. So that would mean that f changes from concave up to concave down, or vice versa. So let's do it like this. 4 times. Since f prime changes from increase to decrease, or vice versa, 4 times, right? Very good. 82. It says if f is a continuous function on a closed interval AB, which of the following must be true? This is a theorem question, and so when we see these questions, you got to do your best to not look at your options, because you'll end up talking yourself into all of the options. So here's what you need to do. You've got f is continuous on a closed interval, and so you have to think, okay, what theorem's conditions is that? And that is extreme value theorem. Okay, so I have met the conditions of EVT, extreme value theorem. Well, let's write that. So I've got the conditions. So then I know that the conclusion is f has an absolute min and absolute max. So there is an absolute largest y value, and there is an absolute smallest y value. Okay, that's what we're guaranteed. So now we start looking through our options and seeing which one says that, but in math terms, okay? All right, there's a number c where f of c is 0. No, EVT doesn't say anything about having zeros. There's a number c where that y value is between the others. That looks more like an IVT type thing. Okay, there's a number c in the closed interval AB such that the y value there is greater than or equal to all of the other y values. I think that's it. That's what it means to be a max, right? That y value is larger, bigger, than all the others. And that is it. Okay? So for your work shown, I want you to write what I wrote up here. Question 83. The function f is differentiable and has values as shown in the table above. Both f and f prime are strictly increasing on the interval 0 to 5. Which of the following could be the value of f prime of 3? Okay, so we know that both f and f prime are increasing. So what we're looking for f prime of 3, right? So what we can do, at the derivative gives me slope, okay? So what I can do is find the slope between 2.8 and 3, which is going to be a little bit less than the derivative at 3. And I can find the slope between x equals 3 and x equals 3.1, which is going to be just a little bit larger than f prime at 3, the slope of the tangent line right at 3. Okay, and then I hope that just one of the options they give me is between those. All right, so for the first slope, I'll call it m1, I would have change in y, so 45 minus 39.20 all over change in x, so 3 minus 2.8. Let's make the calculator do that. All right, so I'm going to go off of y equals enter, and we will have 45 minus 39.2, and then in the denominator I'll have just 0.2, and that is 29. And then I will find slope between those two. I'm going to call that m2 for slope 2. So that's going to be change in y over change in x. Okay, again, let's make the calculator do that. So 48.05 minus 45 all over 0.1. And I'm getting 30.5. And I need my number to be right between those two, and there's only one option that is. So out of our options, only 30 works. 84. The graph of f prime, the derivative of the function f, is shown above. On which of the following intervals is f decreasing? So f is decreasing, think of your diagram, when f prime, the given graph, is negative. And so that's going to be this piece and this piece. So the domain of those two red pieces will be that. Question 85. The base of a loudspeaker is determined by two curves, y equals x squared over 10 and y equals negative x squared over 10, for x between 1 and 4 as shown in the figure above. For this loudspeaker, the cross-sections perpendicular to the x-axis are squares. What is the volume of the loudspeaker in cubic units? Okay, so if I draw one representative side here, remember area of a square is side squared. So I'm going to integrate from x equals 1 to x equals 4 of top minus bottom, which is minus a negative, so plus, and then square the side. Those are like terms if you want to combine them, but there's no need to because it is calculator active. So integral from 1 to 4 of, open parentheses, x squared over 10 plus another x squared over 10, close parentheses, square all that, dx, and I'm getting 8.184d. Question 86. The function f is continuous and differentiable on the closed interval 3, 7. Okay, so I know IVT, EVT, and MVT all apply. The table above gives selected values of f on this interval. Which of the following statements, this is important, must be true? Okay, so Roman numeral 1, the minimum value of f on the interval 3 to 7 is 12. Does not have to be. Okay, we are just given a snapshot of what's going on. We're just given 5 points out of an infinite number. Okay, that does not mean that out of the 5 they happen to have given us the lowest one here. We don't know what happens in between. It could dip way down, and we don't know. Okay, so this does not have to be true. Roman numeral 2, there exists a c for c between 3 and 7 such that f prime of c is 0. Well, let's try that. F prime, this is MVT, right? Let's write that, MVT. F prime of c will be f of b minus f of a, and I'm allowed to use any values given between 3 and 7, but we'll start with that and test this. F of 7 is 20, f of 3 is 20, and this is indeed 0. So that does work. Okay, that's MVT. Again, if that didn't work, don't assume that none of the others do. You can always, check between 3 and 7, like I could have checked 4 and 5, etc. All right, and then Roman numeral 3, the derivative is positive for values between 5 and 7. Again, we don't know that. Just because these values are increasing doesn't mean that the derivative is always positive. We don't know. These could dip. You could have peaks and valleys between these. You're just given a snapshot, so it doesn't have to be true. It could be, but it says which must. So only 2 has to be true. Question 87. The figure above shows the graph of f prime, the derivative of the function f, on the open interval -7 to 7. If f prime has 4 zeros, 1, 2, 3, 4, on -7 to 7, how many relative max does f have on -7 to 7? So if f should have a max, f needs to go from increase to decrease, meaning f prime needs to go from positive to negative. So let's write that. F has a max when f prime changes from positive to negative, so above the x-axis to below the x-axis, which only happens once. '88. The rate at which water is sprayed on a field of vegetables is given by R of t, where t is in minutes and R of t is in gallons per minute. During the time interval, 0 to 4, what's the average rate of water flow in gallons per minute? Okay, be really careful with this because you see average rate and might want to apply the average rate of change f of b minus f of a all over b minus a, but notice you want the average rate of water flow, and you are given the rate of water flow. Okay, it is already in gallons per minute, and that's what you want here. So what you're trying to do is you're trying to find the average value from 0 to 4 of R of t. Okay, so just look, units will tell you a lot. Okay, we want the average rate of flow, and you are given the function that gives rate of flow. So I want to apply the average value formula, which is 1 over b minus a integral from a to b of whatever function you're trying to find the average of, which in this case is R of t. All right, let's type that in. So alpha y equals, enter, 1/4. Right arrow, math 9, from 0 to 4, R of t is 2 times the square root of 1 plus 5x cubed. We'll go dx here. And I am getting 14.691, so C. 89, the table above gives the values of the differentiable functions f and g and their derivatives at x equals 1. If h equals 2f of x plus 3 times 1 plus g of x, then h prime equals what? All right, h prime of 1. Well, let's find h prime of x first. Any special rules? Product. So we are going to derive the first, which will be derivative of 2f of x will be 2f prime of x. Derivative of 3 is 0. Hold the blue. Plus for product. Now reverse it. Hold the pink. Derive the blue, which will be 0 plus g prime of x. Okay, now let's find these values at x equals 1. So, let's see. F prime of 1 is negative 2. Here I've got 1 plus g of 1 is negative 3. F of 1 is 3. And g prime of 1 is 4. Okay, so now we'll clean this up a little bit here. Let's see, we've got 2 times negative 2 is negative 4. This is negative 2 as well, so negative 4 times negative 2 will be negative 8. This is 6 plus 3, so that's 9, and 9 times 4 is 36. So sorry, I should have been a positive 8 there, right? So 8 plus 36 is your 44. 90, the functions f and g are differentiable for all x. F of g of x is x. Remember this, when they say this, it means that f and g are inverses. Okay, so when we do inverses, we make tables. So we have information for f. So remember we go x, f of x, f prime of x. And then we'll make a table for the inverse, which they're calling g. So x, g, g prime. Okay, let's put in what we know. We know that f of 3 is 8, and f prime of 3 is 9. Okay, so now we're going to switch x and y for inverses, right? X and y switch, and dy dx becomes dx dy, so this becomes 1/9. So now we're just going to match this up. We know that g of 8 is 3, and g prime of 8 is 1/9. 91, a particle moves along the x-axis so that its velocity at any time t greater than or equal to 0 is given by v of t. At t equals 0, the particle is at position 1. What's the total distance traveled by the particle from time t equals 0 to 4? This sentence of at time t equals 0, the position is 1, bears no weight. Okay, we don't care where it started. All we want to know is the total distance. And so for total distance, remember, we go integral from a to b, so 0 to 4 in this case, of the absolute value of velocity. You integrate speed to get total distance. Total distance cannot be negative. So let's do that. We're going to go math 9. Type this in with me. Pause if you need to. Put your calculator. 0 to 4. To get absolute value, you're going to go math, scroll over to number, NUM, and it's the very first one, absolute value. And then we're going to plug in v of t. So 5x e to the negative x, right arrow, minus 1, dx. Thinking. 1.821, so D. Question 92, the last question. Let f be the function with first derivative defined by f prime of x. At what value of x does f attain its max value on the closed interval 0 to 2. So what value of x, okay? So f will have a max when f changes from increase to decrease, right? Which means that f prime needs to change from positive to negative. So let's go ahead and graph f prime. Again, think of this like you would a graphical FRQ. So sine of x cubed, physics people, make sure you're in radians. And then I'm also going to graph y equals 0. We're going to set our window to go from 0 to 2 on the x's, and then I just need to know where it crosses from positive to negative. So let's just go negative 2 to 2 on the y's. Graph. All right, so it's looking like around 1.5. So I would guess C, but let's find it exactly. Second trace 5. If you scroll down to your bottom function, you can move a little faster. Make sure you only ever have 2 functions on your screen when you're doing intersections. If you have more, just do 2 at a time. All right, we're going to get close. Hit enter 3 times, and I'm getting 1.465 if we round. And our work will be since f prime changes from positive to negative there. And that is it.